All right. Good morning, everyone, or good evening, everyone, I should say, and happy Friday. I know it's Friday. I know we're all excited. We get to have the weekend off and everything. Hopefully, I know Saturday or tomorrow it's gonna snow. Hopefully that doesn't happen. But it looks like at least the rest of next week should be super nice. So we have that to look forward to. So today I wanted to make a video for all of you because now we're done with rational everything. We've done solving, we've done simplifying, we've done graphing. We're done. So that mini quiz that you guys took was the wrap up to the unit. Also, side note, if you have not turned that in yet, please do, just so I can give you a grade. Obviously, I'm going to wait as long as possible. I put missings in PowerSchool, but I didn't put a 0. So it's not negatively affecting your grade, just as a quick reminder to please, pretty please, turn those in for me. So today we're going to get started. And as you can see, the new topic, excuse me, is graphing radical functions. So what I mean by radical, the two types of things we focus on are a square root and a cube root. Today we're going to be focused just on graphing square roots and their transformations, so moving them around. Next week we'll talk about graphing cube roots and their transformations. This is a pretty short unit. It'll probably only be about 2 weeks for us, and then we get into the last unit of the year where you guys will have a fun project that'll end the year. But back to what we were talking about here. So here we're going to graph f of x or y equals the square root of x. Now, as I always ask the question when we're in class, what do we do when we don't know what something looks like? Well, I'm going to make a table. The difference is, though, for this one, I can't pick any negative values, right? If you remember from way, way back, if I had the square root of a negative, that's an imaginary number. So my table is going to start at 0. Square root of 0 is 0. I'm going to pick 1 because the square root of 1 is a nice number, 1. Then the next number I'm going to pick is 4. The reason for that is because 4 has a nice square root. It's 2. So my coordinate points that I go to graph now are 0, 0, 1, 1, and 4, 2. So to connect those, I just kind of make this nice curvy thing and go for it. And if you notice at this point, if you pause the video and turn everything sideways, that looks a lot like a parabola. If you remember from way, way back, these are the inverses of parabolas. So it's going to look like you took a parabola and laid it down on its side, right? Unfortunately, I can't really take it and twist it around for you right now, but you would see, actually, wait, I think I can. Let's try it. All right, so if I took this, I copy it, and oh, no, not what I wanted to do. Darn, I guess I can't, but that's okay. I wish I could rotate it for you. But you'll see it looks very, very similar to that, right? So that is what your basic square root of x looks like. It's a parabola laying on its side, and it's only half of it because of the fact that I can't have any, right? The square root of something is never negative also, right? If I'm asking you, if I'm giving you this square root, that means I'm talking about the positive solution, hence why we don't see like the plus or minus here. So moving on, that's your very basic shape. So one important thing to understand, whoops, I forgot I'm on the wrong selection menu here, is that everything will look like that. So I should say everything with a square root will look similar to that. So it may be a little bit taller, it may be a little bit wider, it might be stretched out, it might be a little bit narrower, smashed together and taller, it may be flipped over depending on the number in front. But overall, that's what the basics of what this thing is going to look like. So if I go to my next slide here, I've got 2 other things I want us to graph. So first, let me get a nice little coordinate grid going here. Oh, whoops, I selected the same thing twice. So let me move this to here. Perfect. It's about as good as I'm going to get here, right? So if I look at the first one, right, my f of x equals the square root of x plus 1. Well, all that's going to do is take this picture and move everything up 1. Literally, I'm just going to add 1 to every y value, right? So instead of, if I make my table here, oops, not going to have enough room there. If I make my table for this guy, instead of 0, 0, I'll be at 0, 1. Instead of 1, 1, I'll be at 1, 2. Instead of 4, 2, I'll be at 4, 3. So if I go over here, I'm at 0, 1, 1, 2, and 4, 3. Right? So all that did was take my graph and shift it up 1 unit. Right? Now, for the next one, if you remember what happened with parabolas, right? If I had a plus sign in vertex form, that moved everything to the left. The same thing is going to happen here. Because if I plug in, right, -1, now negatives are okay because this ends up being the square root of -1 plus 1, which is 0. So now my y values are going to stay the same as my original, 0, 1, and 2, but all my x values are going to be 1 less because of the fact that I have this plus 1. Every x value can be 1 less than the nice thing that has a nice square root because I'm going to add 1 to that. So here, for this one, I'm at -1, 0. 0, 1, they share a point. But instead of being at 4, 2, I'm over here at 3, 2. And this guy, let me make that a little bit nicer. This guy looks a little bit something like that. So this, instead of shifting right, this shifted left 1 unit. So you can see if I add on the outside, I go up. If I add on the inside, I go left. So, notice how this behaves extremely similarly to all the other types of graphs we talked about this year. With quadratics, when I added inside, it moved everything to the left. When I added on the outside, it moved everything up. Same thing when we talked about polynomials. If you had x plus 2 as a factor, that made x equal -2, your x-intercept. So everything here, if it's within or underneath something, we do the opposite. If it's on the outside, we do exactly what it says to do. So what that brings us to, and the important thing with all of this, is what we call general form. And you're going to notice that I'm going to use all of the same letters and everything. So for a square root function, your general form is a times the square root of x minus h plus k. Those letters should look familiar. We've used them in every single unit this entire year where we graph stuff, right? So, however, instead of, right, we're used to hk being a vertex, like with absolute value or with quadratics, but you notice with these, we don't have a vertex. We just have a starting point, right? So in my general form here, hk is my starting point, right? A is the same idea. It tells you how tall or how short it's going to be, right? Also understand A, if it's negative, yet we'll flip this thing over. And I'm going to show you a quick shortcut right after we talk about this to graphing that will hopefully be very helpful. Right? And that's your basics. You're never going to see something underneath here that's like a 2x minus 7, right? We may talk about that towards the very end, but not right now, so don't worry about that, right? So what I want to do is go through one example where it has all of these things, and then I can show you the quick way to graph it, and that'll be it for the video today. I know it's going to be a little bit longer than usual because it's a brand new topic and it encompasses a lot, but not the end of the world, right? I won't give you too much to do after this, so hopefully we can still finish everything in the 40 minutes that we have. So the example that I'm going to use here, f of x equals 2 times the square root of x plus 2 minus 3. Okay, so my steps to graphing this, the very first thing I'm going to do is find the starting point. So if I look up at my general form, h is written as subtraction, but I have addition. So for me, that means I'm going to start at -2, -3. The sign flips just like everything else. So I'm going to go here -2, down to -3, put a dot. Perfect. Now the second step is to find the two other points. And amazingly, just like with quadratics, I can take that table and flip it around, right? So 2 I'm going to call use table. Now this table looks a little bit different, right? Now, before, I don't know why I make this center column so large. It doesn't need to be that big. I can do this. There we go. So your first column is still going to be D, representing the distance from the start point. Your center column is going to be the square root of that distance, and your last column is the square root of D times whatever your A value is. So for me, I'm going to pick numbers in the square root of D column here that have a nice square root, right? Or sorry, in the actual D column that have a nice square root. So I'm going to pick 1 and 4 because those have a nice square root, right? Then my center column, square root of 1 is 1, square root of 4 is 2. And then I'm going to multiply, and I'm going to use red here, those by A. So A in this case is 2. 1 times 2 is 2. 2 times 2 is 4. So what this tells me, and again, just like quadratics, I'm using this column and this column. This is your run. That's your rise. So from my starting point, I'm going to go over 1 and up 2 to find this point from my first row. And then again, from here, I'm going to go over 1, 2, 3, 4, and then up 4. 1, 2, 3, 4 to find the other point. And I'm going to connect those dots, just like before, with an arrow. So you're going to use that table the same exact way that you use the table to graph quadratics, except for now, instead of there being like a d squared in your center column, it's the square root of d because we're dealing with a square root function. So I hope that was helpful. Next time what we'll do, we'll talk about what happens, if A is negative. I don't want you to focus on that right now. You're only just going to complete 2 graphs from the worksheet and turn those in so I can give you some feedback. All right, guys, have a great weekend, and I'll see you all on Monday. Bye, guys.